Hello everyone, I'm Tim Doiron, Senior Director of Solution Marketing at Infinera. The title of my presentation today is Unlocked and Unleashed, the case for open and disaggregated networking. So before we jump into much here, let's start by just asking ourselves, what is the purpose of today's network? Today's network really exists to provide automated optical, Ethernet, IP, and MPLS transport services to connect people and applications to the cloud. So where is the cloud? Well, the cloud used to be over there in the data center. That was more of a distant and centralized entity. But of course, we all know that data centers are distributing. And even in fact, the network itself is becoming a data center with edge computing being distributed throughout the network. You know, our networks have never been more important and more of a lifeline. Given the current pandemic, we're actually all realizing that it's not just for entertainment or web surfing at home. Actually, our home networks, turns out they're for university education, for kids that might be in college and at the university. It's for our children's education who are in primary and middle and high school. It's also for us to conduct our jobs and our employment. And so we really see that our networks have never been more important and critical to our overall lives and health and wealth and connectedness. The underlying technology itself that runs our networks is evolving. We have more efficient and capable switching silicon than ever before, and evolving at a rapid pace. We already talked about distributed computing, which is having effects on our network. Coherent optical networking, there's pressure to deal with the increasing capacities at the edge of the network, and so we're pushing coherent technology closer to the edge of the network and into the access and aggregation spaces. And then we also see this bifurcation in optics where we have kind of a low-end optic and a high-end optic. We'd like them both to be high speed and faster speeds, but we may want better spectral efficiency and performance out of one and be willing to pay for it because we're fiber poor in those areas versus something that might not be as efficient spectrally, but yet provide some high capacity connectedness over short distances. When we bring this all together, the reality is traffic patterns in our networks are changing, and it's not like it used to be. And it's leading to a set of challenges for service providers. The first and primary challenge is just simply keeping up with the growth in demand. And we see that growth in the range of 30 to 50% per year, which means that the capacity in our networks needs to double every 2 or maybe 3 years just to keep up. We also see it in, it's getting harder to forecast and forecast demand, particularly in certain areas of the network. I might know it in aggregate what my network's going to do and grow, but do I know what's going to happen at this location? And it's at this location where I actually make purchasing decisions about what to put in there. And so there is a focus on capital utilization and how best to use the working capital that I have. If I underbuy in a given location, I have impacted or have the potential to impact services and service delivery. But if I buy too much equipment or too much capacity in a given part of the network, I've inefficiently or used my working capital or wasted dollars that could be deployed elsewhere. And then the third piece of this is because of that uncertainty in demand and an inability to forecast, service and the growing demand in general, service providers are really looking to avoid long-term lock-in to a purchasing decision they may have made many years ago. And so they're looking for increased agility, flexibility, and choice about the equipment and about the functionality they put into their network, and to be able to constantly refresh and choose a best-of-breed set of solutions. Before we go further into the two product categories I want to discuss today, let's just take a minute to talk about integration versus disaggregation. The reality is, as network vendors and service providers, we're constantly thinking about, do I want to integrate this functionality or do I want to disaggregate this functionality? And that's why I show the pendulum here, because we're constantly bouncing back and forth between those two paradigms. And the reality is, we want to integrate where we can put multiple components or pieces together, and the outcome of putting those together is something that's more valuable or more capable for us. When we want to disaggregate is when we've seen that some component or some portion of an integrated solution is accelerating through an upgrade or innovation cycle faster than maybe the other parts that make up the solution. And we want to be able to support that pace of innovation, or accelerate that pace of innovation in a certain area. And so unlocking that particular component or piece of a solution, i.e. disaggregating it, may be the right thing to do, because it would help us go faster, innovate, or have more focus on that particular aspect of what was previously an integrated solution. So what categories of products do we want to talk about today? We all know about network function virtualization and many of the services that have gone virtual, whether it's session border controllers or firewalls or SIP gateways or whatever. But in today's session, what I want to talk about is disaggregated routing and disaggregated and open optical networking that is also starting to emerge. We won't spend a lot of time talking about common data models and open interfaces and common protocols, but let me just say that is absolutely necessary and a critical part of any disaggregated solution if it's going to be deployable and operational in the real world. So let's jump into disaggregated routing, and the first question to ask ourselves is anybody really interested in a disaggregated routing solution? And the answer is a resounding yes. In this case, this was a survey that we collaborated with Heavy Reading on, and it was about 5G mobile transport. And fully 64% of service provider respondents said that white box routing and switching would either play a critical or a very important role in their 5G mobile transport evolution. So yes, service providers are absolutely interested in disaggregated, open, white box switching and routing. What does such a solution look like as we think about disaggregating routing today? Generally speaking, it's a separation of the routing protocol stack and what's commonly referred to as the network operating system from the underlying hardware. The underlying hardware typically being a pizza box, 1 rack unit, 2 rack unit orientation with merchant silicon that can be supplied from multiple vendors who are participating in the white box switching and routing space. If we want to deploy disaggregated routing, we need to be able to support different capacities in the network at different locations, and we need to do that in a cost-effective manner. So the way we accomplish that is with a combination of stacking and what we refer to as horizontally scalable routing. This is an important aspect that is embedded into our, in our case, our software operating system, our CNOS operating system, and it enables service providers to deploy a single pizza box unit. If they run out of capacity or want redundancy, they can add a second unit or a third unit interconnected through optical interconnect cables. And if they run out of that capacity, we can introduce fabric units and scale this out in a horizontal manner where we have multiple line units feeding multiple fabric units for additional scale, capacity, resiliency, and growth. It really enables a pay-as-you-go, pay-as-you-grow methodology. So let's do a little compare and contrast. We know what the existing solutions look like. We've all built and deployed those for years with the software, the hardware, the line cards, the fabric units, and maybe a network management system, all coming from a single vendor. In the case of disaggregated routing, we're enabling an ecosystem of vendors to provide the hardware. We're using a more open operating system like Open Network Linux. And then finally, we've got the network operating system with the routing protocol, stack, support, and software wrapped up into a NOS and supplied via a vendor like Infinera. What you see from that total solution is the following. We have more choice because we can select the software vendor from the hardware vendor, and we have choice in hardware vendors. We have modularity with a pay-as-you-go, pay-as-you-grow with stacking and horizontal scalability. And then the last piece that I think is critical is this faster networking velocity. Because we're dealing in self-contained pizza boxes, we have the ability to insert the next round of merchant switching silicon into the network at a faster pace. Simply add a new pizza box or swap out one of the white box hardware pizza boxes that's already there when the next silicon is available with the same network operating system, and you've rapidly adopted this next round of silicon evolution. It's nice that people are interested, but is anyone really deploying? The answer is yes. Last year we announced Telefonica as part of the Telecom Infra Project DCSG, or Disaggregated Cell Site Gateway Deployment Model, where we're providing the solution for that. And then most recently, Vodacom in South Africa announced a live commercial trial with us providing the Infinera, providing the network operating system software, and EdgeCore Networks providing the underlying DCSG hardware in that case. So let's switch from routing to optical networking here for just a minute, and again ask ourselves, is anyone interested in open and disaggregated, and if they were, what do they want? Well, when we combine what service providers want from an innovation and a technology perspective with what they want from an open and a disaggregated perspective, what we see is that they really want leading edge capacity per wavelength, and they want to decouple the transponder or the originator and terminator of wavelengths from the optical line system that switches and controls those wavelengths. And they want to do that because the heart of the optical network is really the optical engine that consists of the analog optical front end and the digital signal processing back end. That optical engine evolution is somewhat analogous to the merchant switching evolution, both of which are kind of at the heart of these systems from a capabilities and a next generation perspective. Let's bring that together and take a look at where is open optical networking going then. So in the left-hand side, we see a closed system compared to an open system where different vendor transponders can run over a common line system. And on the right-hand side, we see this move from kind of purpose-built hardware to sled-based, what we call compact modular solutions, where that entity that network element can take on different roles and personalities based on the sleds that are deployed. In one case, it's a disaggregated transponder because we've populated it with transponders. And in another case, it actually could play the open line system role as well because we've populated it with sleds and hardware associated with a line system. All of this is to bring together the idea that operators can choose best-in-class transponder technology and generational evolution over existing line systems and really create and operate a multi-vendor optical networking environment. Again, what does that look like from a before and after perspective? We know what those closed systems look like. We've all built and deployed those. Here's a look at the stack, and again, it looks a little different than the routing. This is mostly focused around transponder and line system. Also some modularity with the ability to add switching type functions when and if needed. But the types of benefits and results that are being sought are indeed quite similar. More choice. In this case, choice means line system and transponders from multiple vendors. Pay-as-you-grow economics, because we can simply add transponders as the capacity demands dictate or as we need to insert those. And faster network velocity, which in this case means the ability to put in the latest optical engine into the network as fast as possible, because that's what will drive down power, cost, and improve spectral efficiency as well. So again, just like in the routing case, is anyone embracing open and disaggregated optical networking? And the answer is yes. We see it in both forecasts where open optical networking forecasts are growing at double digits versus closed optical networking forecasts. And then we also see it in two other data points with our Groove GX G30 platform. Over 50% of our G30s are actually deployed in non-Infinera line systems, over non-Infinera line systems. And then last quarter, we also have a data point where over 50% of shipments actually went to non-web scale, non-ICP customers, which is an indication that it's going mainstream and it's moving into the traditional telecommunications service providers and cable operators. So let's wrap this up. Today we looked at routing and we looked at optical networking, and we looked at how disaggregation and open networking is impacting those two parts of the network. In the case of routing, we see hardware separating from software. In the case of optical networks, we have transponders separated from line systems. We know that we need pay-as-you-go, pay-as-you-grow scalability. We're achieving that with single node deployments and routing, stacking, and horizontal scalability. We're achieving that with transponder versus line system, but also compact modular sled-based form factors are giving us that in the optical networking side. We also want to increase this networking velocity, and we're doing that with pizza box-based orientations, which are giving us the ability to put new packet silicon into the routing and switching domain faster, and enabling us to do something similar with the next generation optical engines with disaggregated transponders in the optical network. While these two disaggregated and open solutions may look different between routing and optical networking, the reality is the same types of outcomes are present. More choice, better economics, and faster networking velocity with next generation engines going in as fast as we can do it. And so despite some diversity between open and disaggregated approaches by product categories, in this case routing and optical networking, we still can unlock and unleash the network. Thank you very much for your time.